Actually, we all need to configure the host. But we don't seem to have configured the internet now. Because what we are actually using now is the way of automatic acquisition. DHCP is a must. It's not just a matter of cumbersomeness. Manual configuration has some disadvantages. For example, I am now going to configure an address for my computer. I choose manual configuration. First of all, manual configuration is a lot of work. You can easily configure address conflicts. For example, you are now operating a network. There may be hundreds of devices in this network. You need to plan the network segment. You also have to remember who used each previously assigned address. You can't assign duplicates anymore. Otherwise, address conflict. It's easy to go wrong. It can be avoided. But there is one circumstance that cannot be avoided. Or you can't use manual configuration. That is, when you are in a public place. There is no way to configure it manually. If you go to a coffee shop and have a cup of coffee, you can't tell the clerk, connect to their Wi-Fi. Let them assign you an IP. This is impossible. If you want to connect to the network inside the coffee shop, surf the web through their devices, you need to configure an IP. Then this IP needs to be on the same network segment as the internal configuration of the coffee shop. Just find the gateway. At least there must be parameters in the internet address configuration. If we all use manual configuration now, then the internet will be very inconvenient. So there are some scenarios where there is no way to manually configure, because this function has a relatively certain threshold, and it's too much trouble. So we now use more dynamic configuration. Dynamic configuration is what we call DHCP today. Dynamic configuration requires running DHCP between the server and the client. It's easy for the client. You don't need to type the command. The client is a graphical interface. You just need to click this directly to run the protocol. But the router side needs to be configured. Then let them be based on the DHCP protocol. Automatically send some address parameters to the host. This DHCP server does not need to purchase the hardware of the DHCP server separately. For example, it can use a router, layer 3 switch, firewall. This can be simulated. They can simulate a DHCP server like this. That is, DHCP server configuration can be done directly on other devices. You don't need to buy a separate server. Let's take a look at how DHCP works. Look at this picture. There are two devices. The device requests an address from a server. Then assign the address. Okay. Let's look at the message type next. This is a topology. Let's wait for the configuration. It will be configured as a DHCP server. Next, here are the two devices. This is the client. It is a very standard CS architecture. It's a client-server architecture. The client asks the server for some services. The server provides corresponding services to the client. This is called the CS architecture. In this schema type, we need to know how DHCP works. Then we need to know which messages DHCP will send. Let's just look at the first four. We don't really need the latter two during the request phase. For messages, let's take a closer look at the sending rules. First of all, here is a DHCP discover. This is called the seek message. When the client looks for the server, first it sends the message. Since it wants to find this server, definitely send packets. If you send a data packet, you must perform data encapsulation. If you want a package. So how to encapsulate the source IP and destination IP? This is the only interesting thing in the boring configuration in DHCP. Now there is no IP to request IP. That must have no source IP. But if you don't fill in the source IP, can't send packets again. When we talked about IP addresses earlier, speaking of some special IP addresses, for example 40, in addition to representing any address on the entire network, make a default route other than. It can actually represent the unknown. Represents no IP now. The destination IP is called the network-wide broadcast address. Is also a restricted broadcast address. 4255. Binary is all 1. For 255 reps. Now all devices only need to receive this message. Must be processed. This is called the network-wide broadcast address. So the first message sent by PC1. That is. This DHCP discover is such a message. The second layer is packaged like this. Then once the message is sent, the switch only needs to be powered on. Then both PC4 and R1 will receive. After receiving R1, found that a device is asking it for an address. It is a server. Then it has to reply to the address. It provides this service. When R1 replies to it, it is necessary to reply to it with a second message type, called DHCP offer. There will be some parameters in the reply message. It will carry what address it wants to assign to this device. And I want to emphasize to you a question. When the PC sends a message, the second layer of encapsulation source MAC must be itself. The purpose MAC must be all 1. Actually, when the server receives this message, it is able to learn this PC's MACs. So, when the server replies to the packet, in fact, it can be unicast back and forth. Because as a PC, it will look at the second floor first. Then look at the third floor. It can directly turn the destination IP into a unicast. Inside Cisco. When it responds to an offer. Broadcast. Although it can learn the MAC address of PC3. But it doesn't. It will send a broadcast. Then both devices can receive. Certainly. Because for the device is the request made by PC3. So PC3 will receive. PC4 is not requesting now. So it's not replying to what you sent. Just know the way. This is called a DHCP offer. It will be carried in the offer. What address do you want this device to use? For example, you have planned some addresses here. Used it. Then when it received, it will reply again. It will reply a request. In this request message, will carry some address it now wants to use, including the server it chooses. Some students may ask, what is the selected server? Isn't this just a server? Sometimes we are in some network environments. There may be multiple servers. It's a backup problem. For example, now there are a lot of devices in the network. I just point to a server to assign me an address. One day it suddenly went down. Now what about the addresses below? So often there may be multiple servers in an environment. If there are multiple servers, it will face a problem. When the PC sends a broadcast packet to find the address, both servers will receive. Then as long as server receives it, it will reply. Now the address that the PC replies to is not the same. This PC is about to choose whether to use device 1 or device 2 as your own server. And what exactly is the address given to you by device 1? Or the address given to you by device 2? So in this DHCP request, we'll carry the address you want to use, and the server you want to choose. And the packet you sent is a broadcast packet. Suppose now you want to select device 1. It assigns you an address of 1.1. Device 2 assigns you an address of 3.1. It is also possible that it is not on the same network segment. For now, You send a broadcast packet.